When installing underground storage tanks, proper grounding is essential for safety and code compliance. The question of whether to connect the grounding wire to a remote ground rod or the building grounding electrode system is a common one. The recommended practice is to connect the number 8 ground wire to the building grounding electrode system rather than a remote ground rod. There are several reasons for this recommendation. Firstly, the National Electrical Code, specifically Section 547.5, requires that underground storage tank systems be connected to the building grounding electrode system. Connecting to a remote ground rod is not in accordance with the code. Secondly, connecting the ground wire to a remote ground rod can create a ground loop. Ground loops can lead to interference with communication systems and electrical equipment. Thirdly, the building grounding electrode system is designed to provide a low-resistance electrical connection to the earth. Connecting the tank to this grounding system ensures that any static electricity generated will be safely discharged into the earth. Fourthly, having all grounding connections go back to the building grounding electrode allows for easy maintenance and inspection. It also simplifies troubleshooting any electrical issues. When installing the grounding wire, there are a few additional considerations to keep in mind. Firstly, if the grounding wire is run through a conduit, it must be insulated. Secondly, the grounding connection should be made using a corrosion-resistant Underwriters Laboratories listed clamp or connector. Thirdly, the grounding system should be tested regularly to ensure its integrity. In summary, for proper grounding of underground storage tanks, the number 8 ground wire should be connected to the building grounding electrode system rather than a remote ground rod. This ensures compliance with the National Electrical Code requirements, avoids ground loops, and provides a centralized grounding point. Grounding electrode systems are designed to provide a safe path for electrical fault current to return to the source, typically the utility transformer. This path helps to trip circuit breakers or fuses, disconnecting the power and preventing electrical shock hazards. The building grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes, connected together to form a low-impedance path to earth. The connection to the underground storage tank system helps to equalize the electrical potential between the tank, the surrounding soil, and the building's electrical system. This equalization reduces the risk of static electricity buildup and discharge, which could potentially ignite flammable vapors present in the vicinity of the tanks. Ground loops occur when there are multiple paths for ground current to flow. These multiple paths can create circulating currents that can interfere with sensitive electronic equipment and cause other electrical problems. By connecting the tank grounding wire directly to the building grounding electrode system, a single, well-defined ground path is established, minimizing the risk of ground loops. Using corrosion-resistant connectors is crucial because underground environments can be harsh and corrosive. Over time, corrosion can degrade the grounding connections, increasing the impedance and reducing the effectiveness of the grounding system. Underwriters Laboratories listed connectors are designed and tested to withstand these harsh conditions and maintain a reliable electrical connection. Regular testing of the grounding system is important to ensure that it remains effective over time. Testing typically involves measuring the resistance of the grounding system to earth. A low resistance indicates a good connection and an effective grounding system. Higher resistance indicates a problem, such as corrosion or loose connections, which needs to be addressed. In addition to the requirements of the National Electrical Code, local regulations may also apply to the grounding of underground storage tanks. It's important to check with the local authorities to ensure compliance with all applicable codes and regulations. The size of the grounding wire, in this case, number 8 American wire gauge, is determined by the size of the electrical system and the potential fault current. The National Electrical Code specifies the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. It's important to consult the National Electrical Code to determine the correct size of grounding wire for a specific application. The building grounding electrode system should be installed in accordance with the National Electrical Code requirements. The code specifies the type of grounding electrodes that are permitted, the methods for installing them, and the requirements for bonding them together. Proper installation of the grounding electrode system is essential for ensuring its effectiveness. The connection between the grounding wire and the underground storage tank should be made in a way that is mechanically strong and electrically sound. The connection should be protected from corrosion and physical damage. The use of a suitable clamp or connector is recommended. The grounding system should be inspected periodically for signs of corrosion, damage, or loose connections. Any problems should be corrected promptly. Regular maintenance of the grounding system is essential for ensuring its continued effectiveness. If the underground storage tanks are located in an area with high soil resistivity, it may be necessary to install additional grounding electrodes to achieve a low impedance ground path. Soil resistivity is a measure of how well the soil conducts electricity. High soil resistivity can make it difficult to establish a good ground connection. The type of soil in the area can affect the effectiveness of the grounding system. Sandy soils tend to be more conductive than rocky soils. The presence of moisture in the soil can also improve its conductivity. In some cases, it may be necessary to treat the soil with a chemical compound to improve its conductivity. The location of the grounding electrode should be chosen carefully to avoid interference with other underground utilities. Grounding electrodes should be located away from water pipes, gas lines, and other buried utilities. It's important to consult with the local utility companies to determine the location of underground utilities before installing grounding electrodes. The grounding system should be designed to minimize the risk of stray voltage. Stray voltage is a voltage that can occur on grounded metal objects such as underground storage tanks due to electrical imbalances in the power system. Stray voltage can be a safety hazard. The grounding system should be designed to provide a low impedance path for stray voltage to return to the source. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. It's important to consult the National Electrical Code to ensure that the grounding system is installed in accordance with the code requirements. The grounding system should be designed and installed by a qualified electrician. A qualified electrician has the knowledge and experience necessary to design and install a safe and effective grounding system. The grounding system should be documented. The documentation should include a description of the grounding system, the location of the grounding electrodes, and the results of any tests that have been performed. The documentation should be kept in a safe place. The grounding system should be reviewed periodically to ensure that it is still effective. The review should be conducted by a qualified electrician. The grounding system should be upgraded if necessary. The grounding system should be upgraded if there are any changes to the electrical system or if the grounding system is no longer effective. The grounding system is an important part of the overall electrical safety system. A properly designed and installed grounding system can help to protect people and property from electrical hazards. The grounding system should be maintained in good condition. Regular maintenance of the grounding system is essential for ensuring its continued effectiveness. The grounding system should be inspected periodically for signs of corrosion, damage, or loose connections. Any problems should be corrected promptly. The grounding system should be tested regularly to ensure that it is still effective. The testing should be conducted by a qualified electrician. The results of the testing should be documented. The documentation should be kept in a safe place. The grounding system should be reviewed periodically to ensure that it is still effective. The review should be conducted by a qualified electrician. The grounding system should be upgraded if necessary. The grounding system should be upgraded if there are any changes to the electrical system or if the grounding system is no longer effective. The grounding system is an important part of the overall electrical safety system. A properly designed and installed grounding system can help to protect people and property from electrical hazards. In conclusion, when dealing with underground storage tanks, prioritizing a connection to the building's grounding electrode system, as opposed to an isolated ground rod, is critical for both safety and compliance. This method ensures adherence to the National Electrical Code, minimizes ground loop potential, simplifies maintenance, and promotes efficient dissipation of static electricity. Always engage qualified electricians for design, installation, and regular inspections to guarantee the grounding system's integrity and effectiveness. This approach will contribute significantly to a safer operational environment.